Chapter 1. Unveiling Stellar Spectacles. Beyond Our Backyard. For millennia, humankind has looked to the skies. We have charted the constellations, told stories of gods and heroes, navigated oceans by the stars. But what we once saw as mere twinkling lights are in truth colossal engines of creation. Every star is a sun, every sun a forge, and every forge a story. To understand them is to begin to understand the universe and ourselves. Tonight we venture beyond the warm glow of our own sun, stepping outward into a realm where the ordinary rules of Earth dissolve into the extraordinary ballet of the cosmos. A universe of blazing stars, swirling exoplanets, and titanic black holes awaits an endless theater of spectacle unfolding in the depths of space. Section 1. The Discovery of Other Worlds. For most of history, we assumed planets circled only our own star. The heavens, so vast, seemed sprinkled with suns, but we believed ours was unique in hosting worlds. That illusion shattered at the close of the 20th century. In 1995, astronomers announced the discovery of the first confirmed exoplanet orbiting a sun-like star 51, Pegasi b, a giant, blistering hot planet racing around its star in just 4 days. Since then, our catalog has grown from one to dozens to hundreds, and now to thousands. Over 5,000 confirmed exoplanets populate our records, and that number climbs steadily with every new mission. Some are gas giants many times the size of Jupiter. Some are rocky Earth-like worlds bathed in starlight. And some orbit in the habitable zone, the cosmic sweet spot where liquid water and perhaps life could exist. The Kepler Space Telescope revolutionized our search, staring at a single patch of sky for years, detecting the faint dimming of stars as planets crossed their faces. Each dip in light was a world, each world a potential home. From Kepler's tireless watch, we learned that planets are not rare. They are everywhere. On average, every star in the galaxy likely hosts at least one. And now, with the James Webb Space Telescope, we've taken a leap forward, not merely detecting distant planets, but studying their atmospheres. As alien light filters through the clouds and gases of a world dozens, hundreds or even thousands of light years away, Webb breaks that light apart, reading its chemical code. Methane, water vapor, carbon dioxide, even hints faint but thrilling of complex organic molecules. In these alien skies, we may already be seeing the first whispers of life. Section 2. Direct Imaging. A glimpse of alien skies. For centuries, exoplanets were invisible. We could only imagine them, hidden in the glare of their stars. But now, with advanced optics, coronagraphs, and space-based instruments, we can see them directly. The faint pinprick of light next to a blazing star, an entire world, revealed by technology that blocks out the parent star's brilliance, letting the planet's glow shine through. It is humbling. A pixel on a screen, a grain of light. And yet, within that point lies a world of oceans, mountains, storms, perhaps forests, perhaps cities, perhaps nothing at all. Each pixel is a possibility, a reminder that what we know is still only a fraction of what there is to discover. Section 3. Black holes and gravitational waves. Narrator. But stars and planets are only part of the story. In the deep, where gravity reigns supreme, lie objects so extreme They defy common sense black holes. Once dismissed as theoretical curiosities, they are now observed, measured, even imaged. The Event Horizon Telescope has shown us the unseeable, the silhouette of a black hole against the fiery accretion disk of matter spiraling into its depths. A cosmic abyss rimmed with light. And then, in 2015, the universe spoke to us in a new language. 2 detectors, one in Washington State, another in Louisiana, registered a ripple in space-time itself. It lasted less than a second, but its story spanned over 1 billion years. 2 black holes, each many times the mass of our sun, had spiraled together in a fatal embrace, colliding in a titanic explosion of energy. That collision sent waves through the very fabric of reality, gravitational waves, predicted by Einstein a century earlier. With that detection, humanity's senses expanded. No longer confined to sight alone, we could now hear the universe. Every new detection since black holes colliding, neutron stars merging, adds to the cosmic symphony. And somewhere, perhaps the notes of this symphony may reveal entirely new physics, new truths, hidden just beyond our understanding. Section 4. The Lives of Stars. Narrator: Stars too are born, live, and die. Their lives span millions, sometimes billions of years, but they are not eternal. They are the beating heart of galaxies, the cosmic engines that forge the very elements of existence. In vast clouds of gas and dust, stellar nurseries like the Orion Nebula, gravity gathers material until the pressure is so immense that nuclear fire ignites. A star is born, blazing with light. Some live quietly like our sun, steady and nurturing. Others burn furiously, massive giants whose lives are brief but spectacular. And when those giants die, they do so with fury supernova, explosions so powerful they outshine entire galaxies for weeks. In those final moments, elements heavier than iron are created: gold, uranium, platinum. Without supernova, the universe would lack the building blocks of planets, of life, of us. Carl Sagan once said, "We are made of star stuff." And it is true. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were born in stars that lived and died billions of years ago. In every heartbeat, in every breath, we carry the legacy of stellar fire. Section 5. Supernova remnants and neutron stars. Supernova do not end in emptiness. Their remnants linger, cosmic sculptures of gas and dust expanding outward in intricate patterns. The Crab Nebula, the Veil Nebula, these are the ashes of stellar death, glowing in colors too vivid to believe. And within some, the collapsed core remains as a neutron star, an object so dense a teaspoon of it weighs billions of tons. Some spin rapidly, emitting beams of radiation like cosmic lighthouses, pulsars, linking across the void with clockwork precision. Others collapse further still, into black holes, leaving behind a shadow in space where once there was a star. In death as in life, stars continue to shape the universe, seeding galaxies with elements, igniting future generations of stars, and perhaps, in time, sowing the seeds of life. Our journey beyond the backyard of our solar system reveals a truth both humbling and exhilarating. The universe is alive with wonders, stars being born, planets circling distant suns, black holes colliding in the dark. It is a place of drama, of beauty, of unending mystery. To study the stars is to study ourselves. For their story is our story, the story of matter rising from the void, of elements forged in fire, of dust becoming life. The cosmos is not beyond us. It is within us. And as we look deeper, we find not only distant worlds, but a deeper understanding of our own place in this vast and dazzling universe. Chapter 2. Galactic Enigmas, Mysteries of the Metagalaxy. Narrator measured curious. The deeper we peer into the universe, the more we realize how little we truly understand. Galaxies spin, yet the matter we see is not enough to hold them together. The universe expands, yet instead of slowing, it accelerates. And though life thrives on Earth, silence reigns across the stars. These are the enigmas of the metagalaxy, mysteries that test the limits of human thought, stretching our imagination to the very edge of what is knowable. Section 1. Dark Matter, the Invisible Web. Imagine looking at a galaxy, a majestic swirl of stars, glowing in spirals of light. By all accounts, gravity should pull those stars into tighter orbits. By all accounts, the outer regions should drift apart. Yet, when astronomers measured the motion of galaxies, something astonishing appeared. The stars on the edges were moving too fast, as if pulled by an unseen hand. The light did not match the mass. The visible matter did not add up. From this discrepancy emerged the idea of dark matter, an invisible substance that outweighs the visible stars, planets, gas, and dust by more than 5 to 1. Though it cannot be seen, its presence is undeniable. It bends light, distorts galaxies, and creates gravitational lenses that magnify the cosmos like colossal natural telescopes. Entire clusters of galaxies reveal its fingerprints, arcs of light warped into strange shapes by the unseen weight of this mysterious matter. And yet, despite decades of study, no one knows what dark matter truly is. Some theories suggest exotic particles, weakly interacting but plentiful. Others hint at undiscovered physics, hidden dimensions, or relics from the birth of the universe. To see a universe filled with stars but not understand what most of it is made of, that is both humbling and haunting. Section 2. Dark Energy, the Accelerating Mystery. But dark matter is only half the puzzle. In 1998, astronomers studying distant supernova expected to see a slowing universe, the natural consequence of gravity pulling everything back together. Instead, they found the opposite. The universe was not slowing down. It was speeding up. Galaxies were racing apart faster and faster, as if driven by an invisible force. That force we call dark energy. Unlike matter, it is not bound, not clustered, not local. It permeates space itself, pushing against gravity, accelerating expansion. It makes up nearly 70% of the cosmos. And yet it is utterly unknown. We can measure its effects, chart its influence, but we cannot touch it, cannot contain it, cannot even say what it is. It a property of space itself? A new field of physics? The echo of something beyond our universe? Together, dark matter and dark energy dominate our reality. They are not side mysteries. They are the main story. 95% of the universe lies in shadow, leaving only a sliver, the stars, the galaxies, the planets, the life we know, as the visible tip of a cosmic iceberg. We live in a universe where what we see is not what is, and what is we cannot yet see. Section 3. The Cosmic Web, Threads of Infinity. Step back even farther, beyond single galaxies, and the true structure of the cosmos reveals itself. With powerful surveys, astronomers have mapped the distribution of galaxies across billions of light years. And what they found was not randomness, not chaos, but order on the grandest scales. Galaxies are strung along vast filaments, stretched into colossal threads, forming a structure known as the cosmic web. In this web, clusters of galaxies act like knots, connected by strands of matter stretching across space, with vast voids between them where little exists. It is a cosmic skeleton, shaped by gravity and dark matter, growing since the dawn of time. If one could fly across the universe at unimaginable speed, one would not see galaxies evenly sprinkled, but rather a vast, interconnected lattice like the neurons of a cosmic brain. Some theorists have wondered, is this structure purely physical, or does it hint at deeper laws? Patterns repeating at different scales, atoms within molecules, stars within galaxies, galaxies within clusters. Is the universe fractal by nature, its architecture echoing itself from the smallest to the largest? And what does it mean that we, too, are part of this web, tiny nodes of consciousness within a universe woven together by forces unseen? Section 4. The Fermi Paradox, the Silence of the Stars. With so many stars, so many planets, and so much time, one question grows louder. Where is everyone? If the universe is filled with worlds, why have we not seen evidence of alien civilizations? This is the Fermi Paradox, a question that cuts to the heart of cosmic loneliness. By all probability, life should be common. The ingredients are simple: water, carbon, energy. And yet the silence is deafening. No radio signals, no alien artifacts, no interstellar visitors, just the quiet hum of stars. Explanations abound. Perhaps life is rare, and Earth is a rare jewel. Perhaps civilizations rise but quickly fall, undone by their own technologies or by cosmic catastrophes. Perhaps advanced life exists but hides, or perhaps it is simply too alien for us to recognize. Some have suggested the idea of a great filter, a barrier that life must pass, but most cannot. If true, then either we have already passed this filter, or we stand on the edge of it still. Still, the search continues. Scientists listen for whispers across the galaxy, radio signals, laser pulses, fleeting anomalies. They look for techno-signatures, hints of vast energy usage, of artificial light, of structures so large they block starlight. And though we have found nothing conclusive, the quest itself is profound. To ask if we are alone is to ask what it means to be human, to wonder if consciousness is a spark unique to Earth or a flame shared across the stars. Section 5. The Philosophy of Mystery. Dark matter, dark energy, the cosmic web, the silence of the stars. Each is a puzzle, but together they paint a deeper truth, that the universe is stranger than our imaginations, more mysterious than our equations. For every discovery, new questions emerge. For every answer, new horizons open. Perhaps the greatest enigma is not the cosmos itself, but our relationship to it. Why are we here, at this moment in time, able to ask these questions? Why does the universe contain not only matter and energy, but consciousness, the ability to wonder, to dream, to search? These mysteries are not merely scientific. They are existential, philosophical, even spiritual. Narrator tone soft, contemplative. The enigmas of the metagalaxy remind us that we stand in the midst of a vast unknown. 95% of the universe lies hidden from sight. The very fabric of reality expands under a force we cannot explain. The stars around us burn brightly, yet the silence of intelligent voices remains unbroken. And across it all stretches the cosmic web, a tapestry of unimaginable scale, binding galaxies together in a structure both elegant and unfathomable. To dwell on these mysteries is to embrace humility, for we are children of a universe we barely understand, explorers on the shores of an infinite ocean. Yet to ask the questions, to seek the answers, is itself a triumph. The enigmas of the cosmos are not barriers, but invitations, beckoning us to look deeper, to think broader, to dream beyond the limits of what is known. For in mystery lies possibility, and in possibility the promise of discovery. Chapter 3. Echoes of Creation, the Early Universe, and Beyond. Every moment of our lives exists within a cosmic story billions of years in the making. A story that began in darkness, with a burst of unimaginable light. To understand who we are and where we are, we must journey backward, past the stars, past the galaxies, past the clusters that stitch the universe together, back to a time before time, when all that would become the cosmos was compressed into a point beyond comprehension. This is the story of creation's echoes, a record written in light, still whispering across the vastness of space. Section 1. The Cosmic Microwave Background, the Universe's First Light. Imagine the universe 13.8 billion years ago. In its first instant, it was a storm of energy, a fireball so dense that matter and light were indistinguishable. For hundreds of thousands of years, the young universe was opaque, filled with a searing plasma of electrons and protons. Light could not travel freely. It scattered endlessly, trapped in a cosmic fog. But then, about 380,000 years after the Big Bang, the universe cooled. Electrons joined with protons, forming atoms of hydrogen and helium. For the first time, light could break free. That light has been traveling ever since, stretched across expanding space, cooling into a faint glow known as the cosmic microwave background, the oldest light in the universe. Discovered by accident in 1965 by Arno Penzias and Robert Wilson, this faint radiation bathes the sky in every direction. At first glance, it seemed uniform, a dull hum of microwaves. But when satellites like COBE, WMAP, and later Planck mapped it in detail, patterns emerged. Tiny fluctuations in temperature, 1 part in 100,000, etched into the fabric of the cosmos. These ripples were the seeds of galaxies, the blueprint of all future structure. In this ancient light lies the fingerprint of creation. The cosmic microwave background is not just a relic. It is a message, a fossilized afterglow, showing us the universe not as we see it now, but as it was in its infancy, a baby picture of the cosmos, preserved for eternity. Section 2. James Webb Space Telescope. Rewriting Cosmic Dawn. For decades, the story of cosmic origins rested on faint hints and mathematical extrapolations. But now we are seeing further back in time than ever before. The James Webb Space Telescope, with its golden mirror and infrared vision, has pierced the veil of the early universe. Where Hubble saw fuzzy smudges, Webb sees entire galaxies, fully formed, shining in the first few 100 million years after the Big Bang. These discoveries are rewriting what we thought we knew. For years, astronomers believed galaxies grew slowly, building over billions of years. But Webb shows massive galaxies appearing far earlier than expected, as if the cosmos raced ahead of schedule. Some contain more stars, more structure, more complexity than our theories predicted possible. Either we misunderstood how galaxies form, or the early universe had secrets yet to be revealed. Even more astonishing are glimpses of the first stars. Population 3 stars, enormous and short-lived, made only of hydrogen and helium, without heavier elements. These titans may have lit up the cosmos, ending the dark ages and seeding the first metals that would one day form planets and life. Webb has not yet seen them directly, but it edges closer with each deep field observation, each spectrum captured from the dawn of time. Section 3. The Big Bang, From Theory to Evidence. The Big Bang, a phrase familiar to many yet often misunderstood. It was not an explosion into space, it was the expansion of space itself. Every point of the universe rushing away from every other, not from a center, but everywhere at once. Time and space were born together in this event, and with them, the potential for everything we know. At first, the Big Bang was only a theory born from mathematics. Einstein's equations hinted at an expanding universe, though he resisted the idea, preferring a steady state. It was Edwin Hubble, in 1929, who showed that galaxies were receding, their light stretched into redshifts by cosmic expansion. The universe was not static, but dynamic. The discovery of the cosmic microwave background decades later sealed the case. The Big Bang was not just plausible, it was inevitable. And yet the theory continues to evolve. Questions remain. What sparked the expansion? Was it a singularity, a point of infinite density, or something else entirely? Did inflation, a burst of exponential growth, shape the cosmos in its earliest moments, smoothing it into the uniformity we see today? The answers lie at the very limits of physics, where general relativity and quantum mechanics collide, and where our theories break down. Section 4. Beyond the Big Bang, Alternate Possibilities. But science is not static. It questions itself, tests itself, reinvents itself. And so we must ask, was the Big Bang truly the beginning? Or was it a chapter in a larger story? Some cosmologists propose a cyclic universe where Big Bangs and Big Crunches follow one another in an endless rhythm. Others speak of a multiverse where our cosmos is but one bubble in a frothing sea of universes, each with its own laws, its own constants, its own story. Still others imagine a quantum birth, where fluctuations in a vacuum gave rise to everything: space, time, energy, matter. We may never see beyond our cosmic horizon, the limit of what light has had time to reach us. But in mathematics and particle physics, in the structure of the cosmic microwave background, hints of deeper truths may still emerge. Perhaps we are only beginning to scratch the surface of a reality more vast, more layered, more astonishing than we can yet conceive. Section 5. Echoes in Us. The echoes of creation are not distant abstractions. They live within us. The hydrogen in our cells formed in the first minutes of the universe during primordial nucleosynthesis. The heavier elements in our bodies were forged later in stars and supernova. Our very existence is an unbroken chain that stretches back to the Big Bang itself. When we study the origins of the cosmos, we are studying the origins of ourselves. To look at the cosmic microwave background is to glimpse the conditions that lead, step by step, to the rise of galaxies, stars, planets, life, and consciousness. The universe remembers where it came from, and through science, so do we. The early universe speaks in whispers, faint light, distant galaxies, subtle fluctuations in temperature across the sky. But from these whispers, we learn volumes. We learn that the cosmos began in fire, expanded in wonder, and continues to evolve. We learn that creation is not an event frozen in the past, but a process unfolding still. And we learn that to understand where we are going, we must always listen to the echoes of where we came from. Perhaps one day we will answer the greatest question: what lit the spark? Until then, we follow the faint glow of ancient light, chasing the story written into the fabric of space and time. For in the echoes of creation, we hear not only the universe's past, but its promise. Chapter 4. The Infinite Horizon. What's next for cosmic exploration? For as long as humans have looked up, the night sky has been both a mystery and a promise. We have mapped constellations, tracked planets, sent probes across the solar system, and built telescopes that reach into the dawn of time. And yet, this is only the beginning. The universe stretches on, boundless and waiting. The question is no longer whether we will continue to explore, but how far, how fast, and how boldly we are willing to go. Section 1. The next generation of telescopes. The James Webb Space Telescope has opened new doors, but it is not the end. In the coming years, an even greater fleet of instruments will rise, each designed to answer questions Webb could only hint at. The Nancy Grace Ramang Space Telescope. Ramang will scan vast regions of the sky, seeking the fingerprints of dark energy and mapping the distribution of galaxies across cosmic history. Where Webb peers deeply, Ramang will cast a wide net, searching for thousands of exoplanets, including potentially Earth-like worlds orbiting distant suns. The European Extremely Large Telescope, ELT. On a mountain top in Chile, the ELT is under construction, with a mirror nearly 40 meters across, the largest optical telescope ever built. With such power, it will resolve planets around other stars directly, studying their atmospheres for signs of life. The Laser Interferometer Space Antenna, LISA. While telescopes capture light, LISA will listen to the ripples of space-time itself. This trio of satellites orbiting in perfect formation will detect gravitational waves from colliding black holes and merging galaxies, vibrations from cosmic cataclysms billions of years ago. Each of these instruments is more than a machine. Each is a key, unlocking doors to mysteries we cannot yet name. Section 2. The Search for Life. If the history of astronomy teaches us anything, it is this. Every time we peer deeper into the cosmos, we find more worlds. Thousands of exoplanets have already been catalogued. Hot Jupiters, super-Earths, frozen giants, scorched lava worlds. But somewhere among them may lie a planet like ours, a blue marble orbiting in the habitable zone of its star. Future missions aim to go beyond discovery and into detection, scanning atmospheres for oxygen, methane, water vapor, or other biosignatures. One day, we may read the chemical fingerprints of alien life in the spectrum of starlight. And if we find it, everything changes. For the first time, we would know we are not alone. The discovery of microbial life on a distant planet, or even evidence of ancient biology, would reshape philosophy, religion, and science alike. Humanity's sense of place in the cosmos would shift forever. Section 3. Becoming an interstellar species. Yet discovery alone is not enough. If humanity is to survive the test of time, we must look outward, not just with instruments, but with our presence. The dream of interstellar travel has long been confined to science fiction. The distances are staggering. Even the nearest star system, Alpha Centauri, lies over 4 light-years away. With today's fastest spacecraft, it would take tens of thousands of years to arrive. But new concepts are emerging. Breakthrough Starshot, a fleet of tiny, sail-powered probes propelled by powerful Earth-based lasers, capable of reaching a fraction of light speed. Within decades, they could fly by another star, sending back images and data. Fusion propulsion, harnessing the same reaction that powers the stars. Fusion drives could slash interstellar travel times from millennia to centuries. Generation ships and cryosleep. If faster-than-light travel remains a dream, we may instead build vast vessels, cities among the stars, where generations live and die en route to distant worlds. Others imagine suspended animation, a deep sleep allowing travelers to awaken centuries later in alien sun's embrace. Each of these paths is daunting, yet each represents not impossibility, but challenge. And humanity has always risen to challenge. Section 4. The Great Unknowns. Beyond technology, questions loom. What if we reach the stars and find silence? What if the Fermi paradox, the eerie contradiction between probability and observation, holds true, and intelligent life is rare beyond comprehension? Or conversely, what if the galaxy teems with civilizations, hidden, waiting, or uninterested in speaking with us? The search for technosignatures, radio signals, laser flashes, artificial chemical compounds continues. Perhaps in some forgotten corner of the Milky Way, someone has already sent a message, still racing across space toward us. If we listen long enough, we may yet hear the echo of another mind. Section 5. The Human Horizon. Exploration is not just about science or technology. It is about survival, meaning, and legacy. To gaze outward is to refuse stagnation. To build ships, to send probes, to seek other worlds, these are acts of hope. The stars are not only destinations, they are mirrors. They reflect back to us who we are and who we might become. Will we carry our divisions with us or rise as one species, united by the vastness we share? The answer lies not in the stars themselves, but in us. The horizon is infinite. There will always be another galaxy to study, another star to chart, another mystery to unravel. But each step brings us closer, not only to understanding the universe, but to understanding ourselves. The universe is not closed to us. It is open, an endless book with pages waiting to be read. We are the authors of the next chapter. Whether we remain confined to our small world or venture into the vast ocean of space will define the destiny of our species. In the end, the cosmos calls to us with a simple truth. We were born from the stars, and perhaps one day we will return to them. From the echoes of creation, to the birth of stars and galaxies, to the mysteries of dark matter and the dream of life beyond Earth. Our journey has carried us across the vast tapestry of the universe. We began with wonder, staring into the cosmic canvas, humbled by the scale of what lies beyond our small world. We unveiled stellar spectacles, peering into the lives of suns and the cataclysms of black holes. We traced galactic enigmas, chasing invisible forces and questioning whether we are alone. We listened to the echoes of creation, hearing whispers from the dawn of time. And at last we looked to the infinite horizon, daring to imagine what humanity's future among the stars might hold. Every discovery reminds us we are part of something larger. We are the universe, awake and aware, capable of asking the questions no star or galaxy could ever ask of itself. We are not outsiders gazing upon creation. We are its children, shaped by its laws, born of its elements, carried by its mysteries. And though the cosmos may seem infinite and indifferent, it has given us the greatest of gifts, curiosity. It is curiosity that pushes us to build telescopes, to launch probes, to look up at the night sky and wonder. It is curiosity that whispers, "We are not finished yet." The story continues. The greatest chapters have not yet been written. The universe is vast, eternal, mysterious. But it is not beyond us. It is within us. And as we stand at the edge of the infinite horizon, we are reminded that the cosmos is not only out there to be explored, it is in here waiting to be understood. For in searching the stars, we discover the deepest truth of all ourselves.